In this video, we're going to go over the last two examples, which are multi-step mole problems. So look at this next example. Calculate the number of atoms present in 4.29 grams of phosphorus. So you always start by writing what's given. 4.29 grams of phosphorus. Then, remember, whatever unit you're trying to get rid of, that unit comes down here at the bottom. So I put grams of phosphorus down here. Then I look at my periodic table to determine the molar mass. So it's 30.97 grams of phosphorus. I know that 30.97 grams of phosphorus is equal to 1 mole of phosphorus. But I'm looking for atoms, I'm not looking for moles, so I have to keep going. Once the unit you want ends up at the top, that's when you stop. So I keep going. I put 1 mole back down here at the bottom because I need to get rid of the mole. So I put 1 mole of P down here. I know that 1 mole of phosphorus is equal to 6.02 times 10 to the 23 atoms of P. So when I calculate now, I always put in my given first, 4.29. I personally work left to right, but you can go across the top first if you want, and then the bottom. But I'm going to divide by 30.97 because the 30.97 is in the bottom. I'm going to multiply by the 6.02 second EE 23 because it's in the top, and then equal. I'm looking for 3 sig figs for my answer, so I would record my answer as 8.34. Notice though, there's an EE in my answer. So that means times 10 to the number behind that is my exponent. 8.34 times 10 to the 22nd atoms of P. Alright? Let's look at the last example. Calculate the mass of 2.410 times 10 to the 22nd atoms of gold. I always start by writing my given. 2.410 times 10 to the 22nd atoms of gold, which is AU, times a conversion factor because I need to switch from atoms to the mass. So remember, whatever unit you're starting with, that unit goes down here at the bottom. So I have to put atoms of gold down here. Now what number is always going to go with atoms? That's going to be Avogadro's number, 6.02 times 10 to the 23. And I know that 6.02 times 10 to the 23 atoms of gold is equal to 1 mole of gold up here. But I'm not done because I'm looking for the mass, I'm looking for grams. So I'm going to times this by, again, I'm trying to get rid of the moles, so I'm going to put that down here, 1 mole of gold. And I know from my periodic table that 1 mole of gold is equal to 196.97 grams of gold. So I'm going to plug this into my calculator. I always put my given first, 2.410, second EE, my exponent 22. I'm going to divide by 6.02, second E, 23 because it's in the bottom. I'm going to times it by 196.97 because it's in the top. And I'm going to have 4 sig figs for my answer because there's 4 sig figs in the given. So I'm going to record my answer as 7.885 grams of AU. I want to point out not to do any funny business in the calculator. What I mean is, don't do a 2.410 times E 22 divided by 6.02 times E 23. We don't want to do that. That's funny business. If you put a times and an E, or a times and a 10 and an E, you're going to make some mistakes in the calculator. So always just use that EE function and don't do any, what I like to call, funny business. So if you all have any questions, just let me know. Happy moling!